Determine if the sequence an equals n plus minus 1 to the n over n times n squared over 2n plus 1 quantity squared converges, and if so, what's the limit? So the problem is asking us to work out the limit of the sequence an. In other words, the limit is n tends to infinity of n plus minus 1 to the n times n squared over 2n plus 1 quantity squared. Now our typical approach is to find an underlying function, a nice continuous function we get by replacing the n's by x's. Unfortunately, this sequence has a term of minus 1 to the n, the oscillator, and that means that there's no nice underlying function to work with right here. And so we can't just take one simple limit using Calc 2 tools. But what we could do is we could examine the two halves of this sequence. We could take a look at what happens for an when n is even, and then we could take a look at the sequence an for n odd and see what happens to every other term. So let's do this as two separate problems. If n is always even, then our sequence takes the form an equals n plus 1, since minus 1 to an even power is even, times n squared over 2n plus 1 quantity squared. And now we can investigate the limit as n tends to infinity of just the even n terms. The nice part is this has an underlying function. We could investigate the limit as x tends to infinity of x plus x squared over 2x plus 1 quantity squared, since we got rid of that alternator. Let's see, if we were to go and expand this out, we're going to have the limit as x tends to infinity. We have 4x squared plus 2 times 2x times 1, or 4x plus 1 squared on the bottom, x squared plus x on the top, and then using the leading coefficients test, we know that this is going to come out to being 1/4 using Calc 1 tools. So that's the same thing as the limit of the sequence, and so we have the limit of an equals 1/4. But remember, this is only for the even terms. The even terms converge to 1/4. Now we could repeat this exact same argument for the odd terms right here. For odd values of n, an takes the form n plus minus 1 times n squared over 2n plus 1 quantity squared, since the alternator is always negative for odd values. So now we want to take the limit as n tends to infinity of these an's. Again, we can use an underlying function. We could take the limit as x tends to infinity of the function x minus x squared over 2x plus 1 quantity squared, since that's what we get now that we have the alternator missing. So this is going to become the limit as x tends to infinity, expanding like we did before. On the bottom we're going to have 4x squared plus 4x plus 1, just like last time. Up top we're going to have minus x squared plus x, just rearranging terms. Again, looking at the leading coefficients, using a Calc 1 test, we see that this limit should be minus 1/4. Since that's the limit of the underlying function, it's the limit of the sequence itself. So we're going to have the limit of an equals negative 1/4 for the odd terms. So the odd terms converge to negative 1/4. Now, putting together the two parts of our argument right here, we see that the odd terms and the even terms don't converge to the same value. And so that allows us to conclude that this sequence right here does not converge. It diverges. In fact, it diverges by oscillating between 1/4 and minus 1/4. And there's our answer.